Okay, this is a little instruction on this homework. Um, and the homework is on asynchronous counters. All right, so the first thing is I give you this 3-bit counter and you can see that I've got it set up. Knowing now how to build, say you build a 6 to 1 and 1 to 6, my suggestion is to make a visual over here, and from that visual you can figure out what it's doing. You look at the inputs and the outputs of the NAND gate, and from that you can figure out how this thing works, and then you can start filling in this stuff. Okay, so the count will reset when the count reaches. If you want to go with a binary or a base 10 number, either one is fine. In the end, it's going to talk about what's displayed. That when they talk about the count range, it's what physically is displayed, and that's what you'd put in there. Okay, and so these two questions really are asking you, from what would be on that visual. All right. And then what's new down here is when I made this back in 2006, I think. So it was a little while ago. You guys were youngins back then. Um, this is a JK flip-flop. I'm going to zoom in a little bit if I can, Control plus. All right. So at that point, I couldn't find a positive edge trigger JK flip-flop in multisim. It's been added since then. So we never used this in class. The one I did find, it had the J and K, but it was an active low K, which is kind of weird. So what I did is I put this inverter in. So in the end, all you have to think about this guy as just a JK, a positive edge trigger JK flip flop. Okay, it's just a whoa, color schemes have changed in Windows 7 Basic. That's cool. So it's just a positive edge trigger JK flip flop versus up here you had the negative edge trigger JK flip flop, which we use a lot of. All right, so that's why there's those little inverters. Now the other thing I want to point out on here is what it talks about. This doesn't have any NANDs controlling the active low asynchronous inputs, so it just does this whole count range. It's either, obviously it has 3 bits, so it's either going to be an up count or down counter. That's pretty easy. The thing I want to point out is this, they call them these mods, mod counter. It stands for modulus, and for short they call it mod. What that means, this modulus thing, what that means is the number of states. Okay, so easy example. Let's say I had a mod for up counter. You'd need to know which way it was going. The reason why is inherently 0 is built into there. Okay, so if it's a mod for up counter, what you would have is a counter going 0, 1, 2, 3. 0 being one of the states, mod for the number of states. So that is a total number of states that it would show. So if it's mod 4, and if it was up, it means it goes 0, 1, 2, 3. 0, 1, 2, 3. And uh, with these guys, since they're not controlled with any, the asynchronous inputs aren't controlled by anything, if you know the mod number, it's also called the divide by as well. That it's going to be the same thing. So think about each one as a divide by 2. Just kind of think through what would happen to that wave, the frequency here, and overall. So when they're talking about divide by, they're talking about what would the final frequency be here. If you kind of do the math, you'll see this number here divides by some number. That would also be equal to the mod, and so that's why if you know the mod number, you also know the divide by. Just kind of interesting. So that's why when I have these mod questions, you'll notice that there's nothing hooked up to the asynchronous inputs. Really important to note that, because then it is also called the divide by whatever. And here I'm giving you some frequencies to calculate out. Down in here you'll notice, because I'm using my active low inputs, I don't start talking about a mod or divide by, because 0 may not be part of my count range. It may not be displayed. So by the way, mod 4 down, if you're thinking about what mod 4 down, well, it'd be 3, 2, 1, 0. All right. So that's that. This is really something that I want you to do at home. And then what I'll probably do is have you swap with somebody else and I suppose you can just check your answers with the answer key. I may swap. I haven't figured that out yet. But in the end, being able to do these questions is vital skill for the final exam. If you can't do this stuff, if you're struggling on these, You really need to, either you don't understand counters at all, which at this point you should be fine with that. You might just be struggling with um, asynchronous inputs and what that all means. Okay, so this last one, if I recall right, you really need the visual to get the answer right. That one's a kind of tricky one, if I remember right. Let's see. I got my answer key right here. Just flipping through. I don't know which one was a tricky one. I like the first one. Was pretty good. That's nice. Uh, yeah, with number 4, both 4 and 5. If you don't make that visual, I'm looking at it really quick. I think it was 4 is gonna mess you up. No, maybe it's 5. Yeah, 5. Sorry. I know with number 5, if you don't make the visual, you're not gonna get the right answer. So you want to make that visual like I showed you with the 1 to 6, 6 to 1 counters. You're gonna want to sketch out a 4-bit truth table, just 0, 0, 0 to 1, 1, 1, and make the what's going to be displayed in the go-to step. Then you'll get number 5 right. Number 4 is helpful. You could probably wing it if you wanted to, but 5 you will not get right if you don't make the visual. Trust me. All right, so that's that. Thank you very much.